All right, a ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? It's always a good idea to start with a decent picture. So here's our vertical wall, and here's the ground, and we have a ladder that's leaning up against the wall. And what's not changing is the length of the ladder, which is 10 feet. A lot of other things are changing though. So let's see, they're saying the bottom of the ladder is sliding out this way, and at the same time, the top of the ladder is sliding down. So let's come up with variables that represent these two lengths. Let's call this length x, which is the distance from the ladder, the bottom of the ladder, and the wall, and we'll let the length from the top of the ladder down to the ground, we'll let that be length y. And we need those to be variables because they're changing as this ladder falls. So we need an equation that relates these three things. Well, this is, I said it's a vertical wall, so we have that this is a right triangle. So that means a squared plus b squared equals c squared. So for us, x squared plus y squared equals 10 squared, or x squared plus y squared equals 100. There's the relationship between the variables. So let's go ahead and differentiate with respect to time, right? We have a rate. This is changing by time. So let's go ahead and do that. So when we take the derivative of x squared with respect to time, we get 2x, but it's with respect to time. dx dt, derivative of x with respect to time, plus, let's do it to the y variable, 2y, the derivative of y with respect to t, and the derivative of 100 is 0. Okay? Now let's look at some of the stuff that we've been given. The bottom of the ladder is sliding away from the wall at a rate of 1 foot per second. That's the change of x that they're talking about. The bottom of the ladder is sliding away from the wall. So x is increasing as the ladder is sliding, the bottom of the ladder is sliding to the right. So the rate of change of that x variable, which is dx dt, is 1 foot per second. Okay? What they're asking for is how fast is the top of the ladder sliding down the wall, so how fast is y changing? That is dy dt. That's what they're asking for. So that's what we're trying to solve for. We have that dx dt is 1, and we'll be able to find x and y. What we're trying to find is dy dt. So they do give us at this point that the bottom of the ladder is 6 feet from the wall. So they're telling us our final position, the bottom of the ladder is 6 feet from the wall. That means x is 6. So we can use our original equation then that relates them to find y. So we'll say 6 squared plus y squared equals 100, or 36 plus y squared equals 100. Subtract 36 from both sides. We get that y squared is 64. We'll take the square root of both sides, and we would introduce a plus or minus, but y is a length, so it can't be negative. So we get y is 8. All right, so we know x is 6, y is 8, and we were told dx dt is 1 foot per second. So let's plug all of this in. We'll start with this equation, 2x dx dt plus 2y dy dt equals 0. X is 6, dx dt is 1, 2y is 8, dy dt is what we're looking for. So now we just have to clean this up a little bit. 2 times 6 times 1, that's 12. 2 times 8, that's 16. Pretty simple from here. Let's just subtract 12 from both sides, get rid of that. And then we need to divide both sides by 16 And we've solved for dy dt. Let's go ahead and reduce this. Negative 3/4. It makes sense that that's negative. Dy dt is the rate of change of the y variable. So remember that this top of the ladder is sliding down, so we do expect that length to be decreasing. We do expect a negative value. So the rate of change of that length, that distance, is negative 3/4 feet per second.